Bash shell scripting. In this nugget, we're going to talk about writing shell scripts. We'll build on what we learned in the introductory Linux series on shell scripting by learning about comparison operators, conditional statements, for loops, and more. Let's get down to it. Let's start our discussion of Bash shell scripting with a quick review of the topics that we covered back in the introductory series. So here's the most important topics that we covered. We talked about comments in a Bash shell script. And comments are just side notes, or notes to the reader, the human reader. And the computer ignores these things. But the comments cover things like who authored the shell script, when it was written, what revisions have been made to the shell script. And the comments also are on certain sections of code, explaining what the various sections of code do. We also talked about executing a script. One way that you can execute a script is to say bash followed by the script name. And another way is you can just type the name of the script and run it like that if the script is executable. Okay, so you can use the chmod command to make the script executable, and then you can just run it like any other program. Variables, we talked about those in shell scripts. Variables just hold data like numbers or names and things like that. But then there were some special variables that we learned about, like $1 and $2, and these were arguments or parameters to the shell script. So sometimes if you run a shell script, you say the name of the script, and then you give it some parameters. Like in the introductory video, we wrote a script that took usernames like Perry and Annie. Okay, and then those particular usernames were parameters to the shell script, and then inside of the shell script, $1 was the first parameter, in this case Perry, $2 was the second parameter, Annie, and so on. Okay, and these were special variables. Other special variables we used were $0, which is the name of the script, and $$, or number sign, and this was the number of arguments that was passed into the script. So for this example up here, $number sign would be equal to 2 because I passed 2 arguments to the script. We talked about if statements in the introductory videos. If statements allow us to make decisions about certain things, test certain conditions, and then depending whether the condition is true or false, we can execute some block of code or not execute it. Okay? So it gives us a way to make decisions and make our program more dynamic. And while loops were like if statements. They tested to determine if some condition was true, but the while loop would actually keep executing the block of code over and over and over again as long as the condition at the top of the while loop is true. Once that condition at the top of the while loop is false, all the code in the while loop gets skipped and the program moves on. Okay, so that was a quick review of the stuff that we covered back in the introductory series. Now let's move out to the Linux screen and learn some more about Bash shell scripting. All right, well, let's go down into the scripts directory from my home directory. And in here, I've created a few example programs that we're going to look at one by one to teach you more about Bash shell scripting above and beyond what we learned back in the introductory videos. Okay, so what I'm going to do is bring up this Emacs window that I've minimized, and this has the example program. This is example1.sh. You can see that's written down here. And remember, shell scripts end with the .sh extension, and the Emacs editor will do some special things for you when you tell it that you're working on a shell script. It does some special coloring of various things, and it also takes care of certain indenting schemes and things like that we'll talk about. Okay. Now, I've opened this up in reverse video. That's why it's a black background. I don't know if you care, but if you type Emacs and then give it the -RV option, it'll reverse the video, meaning it'll put it on a black background, and then all the colors I think come out a lot nicer, and it's easier on the eyes. Okay, that's just my personal opinion. All right, so hope you find this okay. So what we're going to do in this example here is we're going to talk about double quotes and single quotes, special characters, and the backtick character and the backslash character. Okay, so let's start by right here talking about this line. Okay, so right away what we've done here is we've assigned this variable testing equal to this string Moby Dick. Okay, remember, when I put something in double quotes and then I assign it to a variable, everything between the double quotes is assigned to the variable. So that variable testing is equal to M followed by O followed by B, Y, space, D, I, C, K. Okay, so there is what testing is equal to. All right. Now, when I go to print out the value of testing, and I print it in an echo statement, and I put the whole string here in double quotes, then that tells the Emacs, or it tells the bash shell, anytime that you see a variable in the string inside of double quotes, go out and get the value of that variable and substitute it in here. So when this gets printed out to the screen, this is going to get printed out, and it's going to say, here is what Moby Dick looks like in double quotes. Okay, now that's what double quotes does. All right, and we saw that back in the introductory videos. We used double quotes in echo statements, and that's the same behavior we saw then. Okay, but this is single quotes now in this echo statement. So here it says, here's what testing looks like in single quotes. All right. Now, $testing is the same variable, but it's not going to evaluate this variable because I've put this into single quotes. So by putting it in single quotes, you're telling the bash shell, don't evaluate anything. Just print this out literally to the screen, character for character. So when this gets printed out, it's going to say, here is what $testing looks like in single quotes. Okay. It's not going to substitute Moby Dick in for $testing. Okay, so that's the difference between double quotes and single quotes. Now, single quotes, what they're used for is to allow special characters to be part of a string. Okay, so for instance, there's all these special characters, and we already know some of these. $ is what we use to precede variables by. Vertical bar is the pipe command, and when we pipe the output of one command into another. Sharp sign here is for comments. Okay, so we already know that. We start when we put a sharp sign, and then whatever we type after the sharp sign on a line is a comment, and it's ignored by the bash shell. It's just for us humans to read. Okay, the ampersand is to put a process in the background. The question mark and the star are for wildcard characters. Okay, and we see these all the time when we're at the command line. Like if I say ls star.txt, then it will list all the files in the directory that end in .text. The star will match with anything. Okay, this redirects the output of a command to a file. This redirects the input of a command. It takes it from a file. The backtick, we're going to learn in a minute what that does. Same for the backslash. The square brackets have to do with evaluating expressions, and we saw these in the introductory video in like if statements, and we'll see them again in the next example and the one after that. Okay, so all of those things are special characters. They're just some of the special characters. There's more special characters in Bash. I don't want to go into all of them. These are like the most common ones. Okay, so now here, when I say name2, there's this variable now, name2, and I'm saying it's equal to single quote $testing single quote. Okay, now here, because it's in single quotes, just like in this echo statement up here that's still highlighted, okay, that's telling the bash shell, do not go out and get the value of a variable called testing. Just take this as a literal string, like $testing. Okay, and that is the value that's assigned to name2. Okay, so the variable name2 now has in it the string $testing. Okay, now when I go here in this echo statement, this is in double quotes. Okay, this is what the variable name2 is equal to. I put a colon and then I put $name2. So now because this is in double quotes, I'm going to get the value of name2. Well, the value of name2 is $testing. Okay, so that's what's going to be printed out here. It's going to say this is what the variable name2 is equal to, colon, and then it's going to say $testing. Okay, because that's the value of name2. And that's one of the things that we do with single quotes, is that we use them so that we can put special characters into variables and into echo statements and things like that. Okay? Now, another way to deal with special characters is to precede the character by a backslash. Okay? And if you precede the character by a backslash, that's telling the bash shell that the thing that's coming up is a special character, and treat it as, you know, a normal character. Don't treat it as a special character. So here I say name3 equals backslash $testing. So this has the exact same effect as this statement. These two things do the exact same thing, except the second one here assigns it to the variable name3 instead of name2. Okay? But it's saying name3 is equal to $testing. Okay? Now, and when I print this out, I say this is what the variable name3 is equal to, $name3. Go get the value of name3, because this is in double quotes, this echo statement. So it goes to get the value of name3, and it's $testing. Okay? Now, one thing you have to be careful of is don't confuse the backtick with a single quote. Now the backtick is that character, typically it's over by the tab key or up by the number 1 key above the Q there, okay, up in the upper left part of your keyboard. That's where it usually is. And the backtick is a very special character. I actually showed you the backtick in the introductory videos, and when I was going back and watching them, I realized I pulled a fast one on you because I didn't explain exactly what was going on. Okay, so here's an example of when you would use the backtick. So you can use the backtick when you want to evaluate some command and then take the value of that command and stick it in the variable. Okay, so here what I'm saying is I have this variable called space used. Okay, and we did this exact line of code in the introductory programs in one of the examples. So this determines disk usage in a summary format for the home Perry directory, and then this cut minus F1 just pulls out the first field of the output. Okay, which will be the number of the amount of space that the directory is using in kilobytes, that's being consumed. Okay, so what this does, by putting backticks before and after this command, this says that space used is not equal to du space dash s space slash home, whatever. Okay, space used is equal to the output of this command. So when I type this command at the command line, okay, what's going to come out? Like, 5,296 or something. Okay, that's what's equal to space used. That's the value that gets stuck into this variable called space used. And then in the next statement, I can say Perry is using $space used kilobytes. Notice this is in double quotes, so I'm going to get the value of space used, and then I'm going to substitute that value into this echo statement. Okay, so now let's go out to the to the screen here, to the command line, and actually run this to verify, to make sure that it does exactly what we thought it would do as we were walking through it. So to run this script, remember, I can just type /example1.sh as long as I make example1.sh executable, and we talked about doing that back in the introductory videos. Just make sure you do a change mode on the file and give it execute permissions. Okay, so I run this, and now here's the output like we were talking about. Here's what Moby Dick looks like in double quotes. Here's what $testing. The variable name 2 is equal to $testing. Variable name 3 is equal to $testing. And here it says Perry is using 7,836 kilobytes. Okay, so this is the output that we expected to get. If you need to, go back and look at the actual code for the shell script and make sure you understand exactly why all these things are getting output by that code. Okay, now we're looking at example2.sh, and in this particular example, what we're going to talk about are comparison operators for strings and also if-then-else statements. We talked about if-then statements in the introductory videos, and now we're going to extend that to talk about if-then-else statements. Okay, so strings, remember, is a computer science term for a series of characters. Letters, numbers, underscores, dashes, whatever. As long as they're not special characters, then we just enclose them in double quotes, and then everything inside of the double quotes is assigned to the value, to the variable string in this example. So string 1 here is equal to TOMMY. String 2 is equal to CHUCKY. Okay, that's what those two strings are equal to. And now what we're going to do is we're going to compare those two strings with these comparison operators that I talked about in the comments up here. So what this says here is if string 1 is not equal to string 2, then I'm going to do this. Okay? Else, I'm going to do this down here. Now let's talk about what this means, if and then and the else part here. Well, it means sort of what it means in English. Okay, so if I say this sentence to you in English, you'll understand exactly what I mean. I'll say, if it's not raining outside, I'm going to go play Frisbee. Otherwise, I'm going to read a book. Okay, so what am I going to do? Well, I'm either going to go out and play Frisbee, or I'm going to stay in and read a book. What does it depend on? Well, it depends on whether it's raining or not. Okay, well, the same thing works here, right? One of these two statements is going to be executed. Either the part in the then or the part under the else. Okay, so what does it depend on? Well, it depends on whether string 1 is not equal to string 2. So if they're not equal, I'm going to do this statement. And if they are equal, I'm going to do this statement. Okay, so the else is like the otherwise in English. If it's raining outside, I'm going to read a book. Otherwise, I'm going to go out and play Frisbee. Okay, that sort of statement. Okay, I'm going to either read a book or play Frisbee. It just depends whether it's raining or not. Same kind of meaning comes out of this statement. Okay, so what's going to happen here when I actually run this program? Is string 1 not equal to string 2? Yeah, they're not equal to each other because one's Tommy and one's Chucky. They're not equal to each other, so this statement should get printed out to the screen. String 1 is not equal to string 2. Okay, the other kind of string comparison operator is we either use -n or -z, and for that operator we just follow that by one string name. Okay, so I'm saying if -n $string 1. Okay, what does this say? Well, the -n says, is the string non-zero length? Meaning, does it have any characters at all? Okay, and -z says, is it zero length? How would something be zero length? Well, if I said string 1 equals double quotes, not even a space in between them, just butt them right up against each other. If I put the double quotes right up against each other, then string 1 would be equal to the empty string. Okay, it would have zero length, in other words. Okay, so in this case, does string 1 have non-zero length? Yeah, it has non-zero length. It has 5 characters in it or something. Okay, so in that case, I'm going to print out string 1 is not the empty string. However, if string 1 was the empty string, I would not do what's under the then statement. I would do what is under the else statement instead. Okay, so that's a little example of if-then-else statements, and it also shows you the operators that you have available to you for comparing strings. Now let's move out to the command line and actually run this script. I'm going to say /example2.sh, and it says string 1 is not equal to string 2, and string 1 is not the empty string. Exactly what we thought. Now let's move on and talk about example 3. Okay, well in this example, we're going to talk about the comparison operators for numbers. And we saw a couple of these back in the introductory videos, and I'm just going to go through a couple other ones here and make sure we understand them in the context of the if-then-else statements. Okay, so here's all the different operators that you can use on numbers. Okay, -EQ is for equal, -NE is for not equal, -GT is for greater than, -GE is for greater than or equal to. Okay, -LT is less than, and -LE is less than or equal to. Okay, so there's the 6 comparison operators that we have for numbers. All right, and now here I've assigned some values to these numbers. Num1 is 10, num2 is 15, and num3 is 20. Okay, so I've said if num1 is greater than or equal to num2, all right, then I'm going to print out num1 is greater than or equal to num2, and I'm going to actually substitute these values in. Okay, for the variable num1 and num2 because I put a $sign in front. Okay, otherwise, else, I'm going to say num1 is less than num2. All right, so what's the opposite of greater than or equal? Well, if something's not greater than or equal to something else, then it must be less than it. Okay, so that's what these two things. One of these two things is always going to be executed, either the stuff under then or the stuff under else. Okay, well, when's the stuff under then going to be printed out? Well, the stuff under then is going to be printed out if num1 is actually greater than or equal to num2. All right, and if it's not greater than or equal, then we're going to say num1 is less than num2. Okay, pretty basic. All right, then what I'm going to do is use the let statement and assign the addition of num1 and num2 to the variable num4. Okay, so now I'm assigning to num4, basically I'm assigning it the value 25. Okay, so now I'm saying if num4 is greater than num3, do this, and if it's not greater than num3, do this. Well, what's the opposite of greater than? If num4 is not greater than num3, well then it must be less than or equal to num3. Okay, so you see how that works. The opposite of greater than or equal is less than. The opposite of greater than is less than or equal. Okay, so there's the comparison between those two things. Okay, so when we print this out to the screen, what's going to happen? Is num1 greater than or equal to num2? Well, 10's not greater than or equal to 15, so we should print this out. We should print out that 10 is less than 15. Okay, and then is 25, that's what num4 was assigned to, is that greater than 20? Yes, it is. So then the then part should be executed, so it should say 25 is greater than 20. Okay, so again, let's move out to the command line and execute this script. And there we see 10 is less than 15 and 25 is greater than 20. Okay, I bet you didn't know that before we ran the script. Okay, so there's an example, again, of comparison operators for numbers and another example of if-then-else statements. Now let's move on to example 4. All right, well, in this particular example, example4.sh, we're looking at operators that we use on files. Okay, we start here with a couple of assignment statements. So the first assignment statement here, I've said directory1 is equal to /home/Perry. And the next line says file1 is equal to /home/Perry/scripts/example1.sh. Okay, now here, notice there's no quotes around home Perry, there's no quotes around home Perry scripts example1. I'm not assigning the string /home/Perry to this variable directory1. Okay, I'm assigning the actual directory home Perry to directory1. And the same in the next line. I'm not assigning the string of characters /home/p and so on. I'm assigning this file example1.sh to file1. Okay, so now in this if then else statement, I'm testing right here. If -x file1. Well, what does the -x do? Well, -x tests whether the execute bit is set for this particular file. Okay, so is the execute bit set for the file? If it is set, then I'm going to print out to the screen file1 is executable. If it's not set, then I'm going to print out to the screen file1 is not executable. One of these two things is always going to be printed out to the screen. Which one depends on whether this file is executable or not. Okay, fine. So we know what's going to happen here. Well, it depends whether the execute bit is set on that file. It's this shell script. I did set it for that file so that we could just run it from the command line by saying ./example1.sh, and so it is executable. So this statement should be printed out to the screen. Okay. Then the next one says here, if -d file1. Okay, well, -d tests whether a file is a directory. All right, so in this case, file1 is example1.sh. That's not a directory, so this is false. So I'm going to skip this part, and instead I'm going to do the else part and say file1 is not a directory. So it should go on and say home Perry scripts example1.sh is not a directory. Okay, now this last if then else statement adds an extra level of complexity. Okay, for this one, I'm saying if -r directory1. Well, -r tests whether the read permission is set. So is the read permission set for this directory? Okay, then there's this -a. Well, -a is like the English word and. Okay, so what I'm testing here is the read permission set for this directory? And is there execute permission set for this directory? If both of those things are true, then I will print out directory1 is readable and executable. Okay? In any other case at all, one of these is not set, it doesn't have read permission set, or it doesn't have execute permission set, or maybe it has neither one set. Well, in any of those cases, I'm going to say directory1 is not both readable and executable. The else statement will take over in any of those other cases. The only time the then part of this statement happens, and I print out directory1 is readable and executable, is when directory1 is both readable and executable. Okay? So it's like saying I have cake and ice cream. That would be a lie if I didn't have cake, or I didn't have ice cream, or I didn't have cake and ice cream. All right? It's if I'm lying there, if I say if I have cake and ice cream, that is false if either part is not true. All right? If I only have cake and I say I have cake and ice cream, I'm lying. Okay? And so then that's what I'm trying to get across here, right? Is that if both of these conditions are met, it's readable and executable, I print out this one. If they're not both met, then I print out this one. Okay, and we don't know exactly what's true here. We don't know if it's just not readable, or we don't know if it's just not executable, or we don't know if it's both. We just know that it's not both readable and executable. Okay, hopefully I've said that clearly enough now that makes sense. Now what I want to do is move out to the Linux, to the command line here, to the shell window, and run this script, and we're going to talk about exactly what this means in the context of a couple other different things. All right, so let's do that now. All right, so let me run that last script, example4.sh, okay, and what we're going to see here is that it says home Perry scripts example1.sh is executable, home Perry scripts example1.sh is not a directory, and home Perry is readable and executable. Okay, great. All right, now let me do something here. Let me switch over to be the user Annie. Okay, type in Annie's password here, and now I want to have Annie run this exact same script, example4.sh. Okay, well, Annie runs this and says, okay, example1.sh is not executable, example1.sh is not a directory, and home Perry is not both readable and executable. Why did she get different output than I did? And we're talking about the exact same files. Well, that's because Annie doesn't have execute permission on this particular file. Okay? She doesn't have read and execute permissions on my home directory. Okay, that's actually the root of the reason why she doesn't have execute permissions on this file. Okay, if we do a long listing of this directory, we're going to see here that example1.sh right here does have read and execute permissions for the whole world. But if we go back a couple levels and do it, we can't do it. Let's see. Let's go to /home here. We can do that, but I can't go back up. See, I can't go cd ... when Annie's in a directory that she's not allowed to be in. Okay, I switched over to be Annie inside of that directory. It didn't stop me from doing that, but I really have no privileges inside of that directory other than like ls. Okay, so we go back to home and do an ls -l there, and you'll see the Perry directory only has read, write, and execute permissions for the owner, which is Perry. So by Annie being inside of that directory and running this script, she's seeing that Perry is not both readable and executable. It's neither one to her. Okay, that's just the way it's been set up. All right. If she ran it in some other directory, like this Dennis directory, the way that's been set up is that everyone has read and execute permissions for that directory. If she ran example4.sh inside of Dennis's directory, it would come out and say, oh, /home/Dennis is both readable and executable. If she altered the script to talk about home Dennis instead of home Perry. Okay, so this whole idea here of whether something is executable or whether something is writable or readable, it depends on who's running the script and what kind of permissions they have. If I was running the script as root, then you can guarantee that I would have all the privileges available here to the root, because I would be getting these like owner privileges. Okay, and I wouldn't need the privileges to be set for me individually like Annie needs it to be. She would have to either be in my group, or I'd have to set it to like the whole world is readable and executable for Annie to be able to actually have read and execute permission on my directory. Okay, so there's a little bit about that I wanted to clear up about these file operators and what it means to be readable and writable and executable and so on. All right, well, I just want to show you one more shell script before we wrap up this nugget. And this shell script, what we're going to do is we're going to count up the number of normal user accounts on the system and the number of special accounts in the system. So normal user accounts, I'm defining that as accounts that have identification numbers between 500 and 1,000. Okay, and then special accounts are going to be all the other accounts. So a normal user account is like the Perry account or the Annie account or the Charles account, okay? And those accounts have identification numbers greater than 500 and less than 1,000, okay? And then the special accounts in the system are things like root, Apache, operator, and so on. And those accounts have identification numbers either below 500 or really, really large, okay? So that's why I've said between 500 and 1,000 are normal user accounts. Okay, so what we're going to do here is we're going to look through the Etsy password file, okay, and we're going to count up how many normal users we see and also how many special users we see. Okay, that's the general idea. Now let's explain exactly what we do to accomplish that. So the first thing that we do is we actually extract all of the identification numbers from the password file. Okay, so notice my use of the backtick here. All right, so what I'm doing here is I'm printing out the password file and I'm piping that through the cut command, and I'm saying pull out the third field and the delimiter is colon. Okay, now in case you forget about the format of the password file, let's just go out to the screen here and actually print out Etsy password. Okay, so I'm going to print that out to the screen. I don't care that it scrolls by. I just want to look at one particular entry. Okay, so the first field, okay, before the first colon is the name of the user. Okay, the next field is an X for all the users because that says that the password is being stored in some other file. And then the next field is the user identification number. And this is the number that we're concerned about. So it's the third field, and the fields are delimited by colons. Okay, now let's go back to our Emacs window. Okay, so that's what this is saying here. Cut out the third field of each line of this file, and the delimiter for the fields is colon. Okay, so what it's going to do is it's going to print out the field, print out the whole file, cut out these fields, and then store that whole list of answers in this variable called user IDs. User IDs is not going to be equal to like one number, like 35 or something. It's going to be equal to a whole bunch of numbers, 0, 1, 7. It's going to be equal to a whole list of numbers. Okay, now what we're going to do is use that list in a for loop. Okay, now a for loop is like a while loop. We learned about while loops in the introductory videos. What it's going to do is, in a for loop is a different kind of a loop than a while loop. We're going to loop through this code over and over and over again, and what we're going to loop through is for every ID in this list that we've called user IDs. Okay, so in is a special word here. This is a keyword that says this thing over here to the right is a list, and I want to extract things from that list one by one, and each one I'm going to call ID for the time being. Okay, so the construct of the for loop is we say for something, do, and then when we're done that loop, we say done. Okay, so what it's going to do is for every ID in this list, it's going to execute this code over and over and over again until we've exhausted that list. Okay, so what are we going to do for each ID in this list? Well, we're going to check the value of that ID. We're going to say if that ID is greater than or equal to 500 and that ID is less than or equal to 1,000, then we're going to increment user count. And this is how we increment a variable. We say let user count plus equals 1. Okay, that just adds 1 to user count. We started user count as 0 up here. Every time that we execute this statement, it gets 1 bigger. All right, but if the ID is not greater than or equal to 500 and less than or equal to 1,000, so if the ID is not between 500 and 1,000, then we're going to execute this line of code, which says let special count plus equals 1. That increments the special count variable. So that says we found an account that wasn't a normal user account. It was one of these special accounts. Okay, so we're using the idea of the AND command that we learned just a couple minutes ago. We're learning, we're using the greater than or equal and the less than or equal operators to compare numbers and so on. And we're doing this. Notice the use of ID here. This is a variable that we set in the for statement. So it's saying for every ID in this list, now ID is equal to that ID for this iteration. When we come back up, now ID is going to be the next number in the list. Okay, and then we'll do an if statement on that particular ID. Okay, and we'll determine whether that ID falls between 500 and 1,000 and so on. And we're going to do this over and over and over again until this list, user IDs, is exhausted. Okay, once that is exhausted, then we're done the for loop, and then we're going to come down to this echo statement, and we're going to say there are $user count normal users and $special count special users on the system. Okay, so there's our shell script to count up the number of users. Let's go out here to the main screen and execute it. I'm just going to say /user count because I've already made it executable, and it says there are 4 normal users on the system and 35 special users, just what we would expect if you went through the password file and looked it up. All right, well, it's time to wrap up our nugget on bash shell scripting. Let's just review a couple of the things that we learned in this nugget. We talked about comparison operators for strings. Remember, that's the equal sign, the exclamation equals, which means not equal, -n and -z, which test whether a string has characters in it or not. -n means it has a non-zero number of characters, or it has some, and -z means it has 0 characters, or it has no characters in the string. Okay, then we talked about comparison operators for numbers, and we had already seen some of these before. GT for greater than, GE greater than or equal, LT and LE for less than and less than or equal, NE for not equal, and EQ for equal. Okay, so you can test all the various possibilities for 2 numbers. And then we talked about file operators, -r, -x, and -w, tested whether a file had read, execute, write permissions respectively. -d determined if a file was a directory. -f determined whether a file was a regular file, like a non-directory file. And -s just determined whether the file existed and was not empty. Okay, we talked about if-then-else statements, and we also talked about for loops briefly at the end of this. We're going to talk more about scripting in the next nugget. We'll talk about Perl, which is a special scripting language, and we'll try to tie together some of the concepts that we learned in bash shell scripting with Perl. We'll see some of the differences, and we'll also learn how to embed Perl code inside of a bash shell script. All right, well, I hope you found this nugget informative, and thanks a lot for watching.